Hello, in this lecture we will find out the radius of the circle. In the drawing we have a big semicircle. Inside this big semicircle we have two semicircles and also one circle. We know that the length of this line segment is equal to 140 units, and the length of this line segment it is equal to 70 units. Our mission is to find out the radius of this circle. Okay. So first of all, we will define the points, the relevant points here. So the touching point of this semicircle with the biggest semicircle will be defined as A. The center of this semicircle will be defined as B. The center of the biggest semicircle will be defined as O. The touching point of this semicircle with the smallest semicircle will be defined as C. The center of the smallest semicircle will be defined as D. And the touching point of the biggest semicircle with the smallest semicircle will be defined as E. The center of this circle will be defined as F. The touching point of the smallest semicircle with the circle will be defined as G. The touching point of this semicircle with this circle will be defined as H. And finally, the touching point of this circle with the biggest semicircle will be defined as I. We will define the radius of the biggest semicircle as capital R. And we will define the radius of this circle, the small circle, as small r. Small r is the radius of the circle. That is the radius that we are looking for. Radius of the circle. Actually, it is given us in the question that the length of this line segment AF is equal to 140 plus 70 units. So we can write down that AF equals to 140 plus 70, that is 210 units. AF equals to 210 units. But what is actually line segment AF? From the drawing, it is very easy to see that AF is the diameter of the biggest semicircle. Okay, AF is the diameter of the biggest semicircle, and therefore we know that the diameter of any circle or semicircle, it is twice as long as the radius. Okay, so AF is the diameter of the biggest semicircle. Therefore, it is equal to 2 times the radius. The radius of the biggest semicircle is capital R. Therefore, the diameter will be equal 2 times capital R. Okay. And we know that AF equals to 210 units. From this long equation, we will derive that 2R, 2 times capital R equals to 210 units. Here we will divide this equation by 2, and we will get that capital R equals to 200 over 2, that is 105 units. So we actually found out that the radius of the biggest circle equals to 105 units. Okay. That is to say, line segment OF, it is the radius of the biggest semicircle, therefore it is equal to 105 units. Why? Because it starts from the center of the biggest semicircle, that is to say from point O and ends at point F. So line segment OF is the radius of the biggest semicircle, therefore it is equal to 105 units. Likewise, the radius of this semicircle, it is also OA. Why? Because it starts from the center of the biggest semicircle and ends at point A, that is the point of the biggest semicircle itself. That is exactly the definition of a radius, therefore OA, it is also the radius of the biggest semicircle, that is to say it is equal to 105 units. Okay, and it is given us in the question that AC equals to 140 units. But what is actually AC? AC is the diameter of this semicircle, and therefore the radius must be equal to half of it. That is to say, the radius AB of this semicircle is equal to 70 units. AB is the radius of this semicircle. Why? Because it starts from point B, that is the center of this semicircle, and that's at point A, that is a point on the semicircle itself. This is exactly the definition of a radius. So AB equals to 70 units. And BC, it is also for the same reason, BC, it is also the radius of this semicircle, that is equal to 70 units in its length. Likewise, it is given us the question, actually here, this line segment is AE. AE, this letter is E, so it is AE, that is equal to 210 units. Okay, so it is given as a question that line segment CE, this line segment CE, it is equal to 70 units. But CE is the diameter of the smallest semicircle. And because of the fact that the diameter of the smallest semicircle equals to 70 units, therefore the radius must be equal to half of it. That is to say, CD, that is the radius of the smallest semicircle, equals to 35 units. And also DE, that is also the radius of the smallest semicircle, equals to 35 units. Okay. In the next step, we will find out the length of line segment BO. The length of line segment BO, for the drawing it is very easy to see that BO equals to OA minus BA. Again, OA minus BA equals to BO. I'll write it down. The length of line segment BO, it is equal to OA minus BA. BO equals to OA minus BA. So BO equals to OA is the radius of the biggest semicircle that is equal to 105 units. So we substitute OA by 105 minus BA. BA is the radius of this semicircle that is equal to 70 units. Therefore we substitute BA by 70. In conclusion, we found out that BO equals to 105 minus 70, that is 35 units. BO equals to 35 units, so we can write down in the drawing that the length of line segment BO is equal to 35 units. Okay, this is BO is equal to 35 units. Okay, and what is the length of line segment OC? The length of this small line segment OC from the drawing, it is very easy to see that OC equals to OE minus CE. OE minus CE. I repeat again, the length of this small line segment OC is equal to OE minus CE. OE minus CE equals to OC. Repeat again, the length of line segment OC is OE minus CE. OE is the radius of the biggest semicircle that is equal to 105 units, so we substitute OE by 105 minus minus CE. CE, according to what is given as the question, it is equal to 70 units. So we substitute CE by 70. In conclusion, we found out that the length of line segment OC is equal to 105 minus 70, that is 35 units. So the length of line segment OC is also equal to 35 units. We can write down that OC equals to 35 units in its length. OC equals to 35 units. In the next step, I will present to you two new rules, and we will implement the two new rules in our drawing. We actually have rule number 10. according to rule number 10, if two circles are touching each other internally, like in this drawing, the small circle is located inside the big circle, and the small circle touches the big circle at point N. This point N, is the touching point between the small circle and the big circle, or the point of tendency also. So here we have two circles that have an internal notch between them at point N. That is to say, they are touching each other internally at point N. Then according to rule number 10, then the straight line that connects their centers together here, point O is the center of the biggest circle. Point M is the center of the small circle. And OM is the straight line that connects their centers together. So according to rule number 10, this straight line OM passes through their touching point. OM passes through point N. That is their touching point. That is to say, OMN, line segment OMN is one straight line. Okay? And so whenever you have an internal notch between two circles, then the straight line that connects their centers together must pass through their touching point. Here, the straight line OM must pass point N, that is to say, OMN is one straight line. And what is the distance between their centers? The distance between their centers is the straight line OM. And from the drawing, it is very easy to see that the distance between their centers, that is OM or MO, is equal to capital R minus small r. Capital R is the radius of the big circle, small r is the radius of the small circle, and the distance between their centers, or M or D, it is equal to capital R minus small r. Capital R minus small r equals to OM, that is D, that is the distance between their centers. Okay, D equals to capital R minus small r, or OM equals to D equals to capital R minus small r. Okay. Likewise, we also have rule number 11 that talks about external notch between two circles. According to rule number 11, if two circles are touching each other externally, here, those two circles are touching each other externally at point N. Point N is their touching point. Okay, why they are touching each other internally? Because one circle is not inside the other circle, but they are touching each other externally. Therefore, they are touching each other externally at point N. So, in this drawing, we have two circles that have an external notch between them at point N. Then, according to rule number 11, the straight line that connects their centers together, the center of this big circle is at point O. The center of the small circle is at point M. And the straight line that connects their centers together is OM. So this straight line OM, according to rule number 11, must pass for point N, that is their touching point. That is to say, O and M is one straight line. Okay, O and M, line segment O and M, is one straight line. Okay, and what is the distance between their centers. OM is the distance between their centers, because point O is the center of the big circle and point M is the center of the small circle. Therefore OM is the distance between their centers. From the drawing, it is very easy to see that OM equals to capital R plus R. Why? Because OM is one straight line. Therefore OM equals to capital R plus small r. D, the distance between their centers, that is to say OM equals to capital R plus small r. Okay? So we actually can implement those two new rules in our drawing. So if we connect the center of this semicircle, that is to say point B, with the center of this circle, that is to say point F, by a straight line, then according to rule number 11, the straight line that connects their centers together, that is to say BF, must pass from point H, that is their touching point. That is to say BHF is one straight line. BHF is one straight line. And what is the length of BF, or the distance between their centers, is BF, of course. HF is the radius of the small circle, that is to say it is equal to small r according to our definition. Why? Because F is the center of this circle and H is the point on the circle itself. This is exactly the definition of a radius. So FH is the radius of this circle that is equal to small r. B is the center of this semicircle. H is the point on the semicircle itself. So BH is the radius of this semicircle, and we already found out that the radius of this semicircle equals to 70 units. Therefore, BH equals to 70 units, and therefore the distance between their centers BF equals to 70 plus R. So we can write down that BF equals to 70 plus R units. Line segment BF equals to 70 plus R units. In the next step, we will connect the center of the smallest semicircle, that is to say point D. Point D is the center of the smallest semicircle here, with the center of this circle that is located at this point, point F, by a straight line. Okay, we connect point F and D together by a straight line. So this semicircle and this circle have an external between them at point G. That is to say they are touching each other externally at point G. And therefore, according to rule number 11, the straight line that connects their centers together, that is to say the straight line DF, must pass from point G. That is to say DGF is one straight line. DGF is one straight line. Okay. Point F is the center of this circle. Point G is the point on the circle itself. This is exactly the definition of a radius. So GF is the radius of this circle. And here, point D is the center of the smallest semicircle. Point G is the point on the smallest semicircle itself, therefore DG is the radius of the smallest semicircle, that we have already found out that the radius of this smallest semicircle equals to 35 units. And therefore, the distance between their centers FD equals to 35 plus R units. Again, the distance FD between their centers, it is equal to 35 plus R units, 30 R plus 35 units. Okay, so I'm writing down that FD equals to 35 plus R units. Line segment FD equals to 35 plus R units and what is the length of line segment BD? The length of line segment BD, from the drawing it is very easy to see that BD equals to 35 plus 35 plus 35. Again, BD equals to 35. BD equals to BO, that is 35, plus OC, that is also 35, plus CD, that is also 35. So BD equals to 35 times 3, that is 105 units. So we can write down that line segment BD equals to 105 units. In the next step, we will join the center of the biggest semicircle, that is to say point O, with the center of this circle that is located at this point, point F. We will join points O and F together by a straight line. Okay. The biggest semicircle have an internal lunge with this circle. That is to say, they are touching each other internally at point I. Point I is the touching point or their point of tendency. And whenever we have an internal lunge between two circles, like in this drawing, the straight line that connects their centers together, that is to say, the straight line OF must pass from point I, that is their touching point. That is to say, OFI is one straight line. Okay, the straight line that connects their centers together is OF, and OF must pass through point I, according to rule number 10. That is to say, OFI is one straight line. Or line segment OFI is a straight line. Okay, so here OFI is one straight line. So F is the center of this circle, I is the point of this circle itself, therefore Fi is the radius of this circle, that is equal to small r. So Fi equals to small r. What is the definition of line segment OI? The definition of line segment OI, point O is the center of the biggest semicircle. Point I is the point of the biggest semicircle itself. This is exactly the definition of a radius. That is to say, OI equals to capital R, that is equal to 105 units. OI equals to capital R, that is equal to 105 units according to what we have already found out. Okay, and what is the length of line segment FO? The length of line segment FO equals to OI minus FI. Again, OI minus FI equals to FO. So FO equals to OI minus FI. Repeat again, FO equals to OI minus FI. Okay, so FO, the length of line segment FO equals to OI. OI equals to 105 units, so we substitute OI by 105 minus FI. FI equals to small r, so we substitute FI by small r. In conclusion, we found out that the length of line segment FO is 105 minus small r units. So we can write here that FO equals to 105 minus small r units. Okay, so in the next step, I will present to you a new rule, and we will implement the new rule in our triangle FBD. So we will implement the new rule in the green triangle FBD. So the new rule, it is actually Stewart's theorem. According to Stewart's theorem, that is true in any triangle. So the triangle that I will draw here could be any triangle. So this is triangle ABC. The length of side AB or side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. And we also have here line segment AO. This line segment AO equals to D units in its length, line segment BO equals to M units, and line segment OC equals to N units in its length. Then, according to Stewart's theorem, the following equation is true: that A squared times N plus B squared times N equals to BC. BC equals to C units, so it is C. And inside the brackets we have here D squared plus M times N. Repeat again. According to Stewart's theorem, if we have this triangle ABC, that could be any triangle, then in this triangle ABC, the following equation is true: that A squared times N plus B squared times M equals to C, times d squared plus mn. Okay, therefore we can actually implement this Stewart's theorem in our green triangle FBD. So I'll copy the green triangle FBD in a new page and we will implement on it Stewart's theorem. Okay. So this is actually triangle FBD that I copied from the original drawing. We have already found out that side FB equals to 70 plus r units in its length. We have already found out that side FD equals to 35 plus r units in its length. I will not repeat on it. Here we have all the length of the sides, and we have already found out that BD equals to 105 units in its length. And we have already found out that FO equals to 105 minus R units in its length. Okay, and here line segment BO equals to 35 units in its length. Line segment OD, from the drawing it is very easy to see that line segment OD equals to 35 plus 35, that is 70. So line segment OD equals to 70 units in its length. So this is triangle FBD for the lengths. We can implement here Stewart's theorem. According to Stewart's theorem, FB squared times OD plus FD squared times BO equals to BD, and inside the brackets we have FO squared plus BO times OD. So this equation is the implementation of Stewart's theorem in our triangle FBD. Okay, FBD squared times OD plus FD squared times BO equals to BD, and inside the brackets we have FO squared plus BO times OD. So FB equals to 70 plus R. Therefore, FB squared equals to 70 plus R squared times OD. OD equals to 70. So we substitute OD by 70 plus FD squared. FD equals to 35 plus R. Therefore, FD squared equals to 35 plus R squared times BO. BO equals to 35, so we substitute BO by 35. And it is equal, on the other side of the equation we have BD. BD equals to 105 units, therefore we substitute BD by 105. And inside the brackets we have FO squared. FO equals to 105 minus R, therefore FO squared equals to 105 minus R squared plus BO equals to 35 times OD. OD equals to 70, all under the brackets. Okay. In the next step, we will define the number 35 as x, and we will substitute in this equation wherever we see 35 or the multiplications of 35 by x. Okay, and you will get that here we have 70 is 2 times 35, and 35 is x, so 70 is 2x plus R squared times 70. 70 is 2x, so we substitute 70 by 2x plus 35 is x, so it is x plus R squared times 35 is x, so we substitute 35 by x, and it is equal to 105 is 3 times 35, that is to say it is 3x. And inside the brackets we have 105, that is 3x, minus R squared, plus 35 is x, and 70 is 2x, so it is x times 2x. So okay, this is the equation that we got after substitute 35 by x. Okay, in the next step we will divide this equation by x. X is 35, so it is allowable to divide it by x. It is not 0. Here x will get cancelled. Here also x will get cancelled. And here also x will get cancelled. So what is left from this equation after we cancelled x? So we divide it by x. We have here 2x plus R squared times 2 plus x plus R squared equals to 3 times, inside the brackets we have 3x minus r squared plus x times 2x is 2x squared. Okay. Here we will open the brackets. So it is 2 times 2x plus r squared is 2x squared, that is 4x squared, plus r squared, plus 2 times 2xr is 4xr. And we have also plus x plus r squared. X plus r squared is x squared plus r squared plus 2xr. In the other side of the equation we have 3. And inside the brackets we have 3x minus r squared is 3x squared, that is 9x squared, plus r squared minus 2 times 3xr is minus 6xr. According to the algebraic identity, that a minus b squared equals to a squared plus b squared minus 2 times ab plus 2x squared. All inside the brackets. Here we'll open the brackets, we'll multiply this expression by 2. 2 times 4x squared is 8x squared plus 2 times r squared is 2r squared plus 2 times 4xr is 8xr plus x squared plus r squared plus 2xr equals to 3 times, inside the brackets we have 9x squared plus 2x squared is 11x squared plus r squared minus 6xr. In this side of the equation we have 8x squared plus x squared is 9x squared. We have r squared plus 2r squared is 3r squared. And we have 8xr plus 2xr is 10xr. And it is equal, on the other side of the equation, we have 3 times 11x squared is 33x squared plus 3 times r squared is 3r squared plus 3 times minus 6xr is minus 18xr. Okay. Here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step, we will subtract 9x squared from this equation. X squared minus 9x squared is 0. So in this side of the equation, we have x 10xr. That is equal to 33x squared minus 9x squared is 24x squared minus 18xr. Here we will add 18xr to this equation and we will get the 10xr plus 18xr is 28xr. And it is equal to 24x squared. 18xr minus 18xr is 0. So in conclusion, we found out that 28xr equals to 24x squared. Here we divide this equation by x, and we get that 28xr over x is 28r. This is equal to 24x squared over x is 24x. So if we do the 28r equals to 24x. Here we'll multiply this, we'll substitute x by 35. According to definition, x equals to 35. So we substitute x by 35. And we'll get that 28r equals to 24 and x is 35. In conclusion, we found out that 28r equals to 24 times 35. Here we will divide this equation by 7 and we'll get that 28 over 7 is 4, so in total in this side of the equation we have 4r. That is equal to 24 times 35 over 7 is 5. So in total, in this side of the equation, we have 25 times 4. 24 times 5. So 4r equals to 24 times 5. Here we divide this equation by 4 and we get that 4r over 4 is r. And there 24 over 4 is 6. So in total, in this side of the equation, we have 6 times 5. So r equals to 6 times 5. 6 times 5 is 30. So r equals to 30 units. Or small r. So actually, we found out that the radius of this circle small r equals to 30 units. In the next step, I'll summarize the lecture. So in the drawing we have a big semicircle. Inside this big semicircle we have two smaller semicircles and one circle. And we also know that line segment AC equals to 140 units and line segment CE equals to 70 units in its length. And our mission is to find out the radius of this circle. So in the first step, we defined names to the relevant points here, and here the center of the biggest circle is at point O, the center of this semicircle is at point B, the center of the smallest semicircle is at point D, the center of this circle is at point F, and we actually defined capital R is the radius of the biggest circle. Capital R is the radius of this biggest circle, and small r is the radius of this circle. That is the radius that we are looking for. Okay? Capital R is the radius of the biggest semicircle, and small r is the radius of the circle. According to what is given as the question, line segment AF, AE, it is actually line segment AE. This line segment AE equals to 140 plus 70 units in its length according to what is given as the question. Okay? So here AE equals to 140 plus 70 is 210 units. But what is AE actually? AE is the diameter of the biggest semicircle And we know that the diameter of any circle or semicircle is twice as long as the radius. So if the radius of this biggest semicircle equals to capital R, it means that the diameter must be equal to twice the radius, that is to say it must be equal to 2R. Okay? So the diameter of the biggest semicircle equals to 2R, and 2R is AE. AE is 2R, or 2 times capital R, and we have already found out that A equals to 210 units. So A equals to 210 units. So from this long equation we can derive that 2R equals to 210. Here we divided this equation by 2 and we found out that R, or capital R, the radius of the biggest semicircle, equals to 210 over 2, that is 105 units. Okay, so here the radius of the biggest semicircle AO equals to 105 units, and the radius OE, the biggest semicircle, equals to 105 units. In the next step, here it has given us the question that AC equals to 140 units. AC equals to 140 units. But what is AC? AC is the diameter of this semicircle, and therefore the radius must be equal to half of it. That is to say, the radius of this semicircle must be equal to 140 over 2, that is 70 units. So the radius AB equals to 70 units, and the radius BC equals to 70 units in its length. That is the radius of this semicircle. Likewise, it is given us the question that line segment CE equals to 70 units. What is CE? CE is the diameter of this smallest semicircle, and therefore the radius must be equal to half of it. That is to say, the radius of this semicircle equals to 70 over 2, that is 35 units. So the radius CD equals to 35 units, and the radius of this smallest semicircle DE, it is also equals to 35 units in its length. In the next step, we calculated the length of this line segment BO. From the drawing, it is very easy to see that BO equals to OA minus BA. Again, OA minus BA equals to BO. Repeat again. BO equals to OA minus BA. OA is the radius of the biggest semicircle. This capital R, that is equal to 105 units. So we substitute OA by 105 minus BA. BA equals to 70 units. This is the radius of this semicircle, and therefore in conclusion we found out that BO equals to 105 minus 70, that is 35 units. Here, line segment BO equals to 35 units. In the next step, we calculated the length of this line segment CO, or OC. From the drawing, it is very easy to see that OC equals to OE minus CE. Again, OE minus CE equals to OC. Repeat again. OC equals to OE minus CE. OE is the radius of the biggest semicircle, that is equal to 105 units, capital R. And here, CE equals to 70 units, according to what is given as the question. Therefore, in conclusion, I found out that OC equals to 105 minus 70, that is 35 units. OC is also equals to 35 units in its length. Then I presented to you two new rules, and we implemented the two new rules in our drawing. Rule according to rule number 2, or to rule number 10, if two circles are touching each other internally, like in this drawing, we have the small circle is inside the big circle, and the small circle touches the big circle at point N. Therefore, in this drawing, we have two circles that have an internal length between them, that is to say, they are touching each other internally at point N. Then, according to this rule number 10, the straight line that connects their centers together, the center of the big circle is at point O, the center of the small circle is at point M, and the straight line that connects their centers together is OM. So this straight line OM must pass for their touching point, and their touching point is at this point, point N. That is to say, OMN is one straight line, OMN is one straight line. Okay, so whenever you have two circles that have an internal length between them, then the straight line that connects their centers must pass for their touching point. In this case, OM must pass for point N, that is to say, OMN is one straight line. And what is the distance between their centers? The distance between their centers is OM. But what is the value of OM? OM equals to capital R minus small r. Capital R is the radius of the big circle, small r is the radius of the small circle. Therefore, capital R minus small r equals to OM. It is very easy to see it from the drawing. Okay? And then I presented to you rule number 11. According to rule number 11, if two circles are touching each other externally, in this drawing, we have those two circles that are touching each other externally. Why? Because neither of those two circles are inside the other circle, but they are touching each other externally at point N. So here we have an external length between those two circles, that is to say they are touching each other externally at point N. And according to this rule number 11, the straight line that connects their centers together, the center of the big semicircle is at this point, point O. The center of the small semicircle is at this point, point M. And the straight line that connects their centers together is OM. So this straight line OM must pass for their touching point, that is to say from point N. That is to say ONM is one straight line. ONM is one straight line. And what is the distance between their centers? The distance between their centers is OM. From the drawing it is very easy to see that the length of OM is ON plus NM. But because of the fact that ONM is one straight line, it means that OM equals to ON, that is capital R, plus NM, that is small r. So capital R plus small r is the distance between their centers. Okay, in the next step we actually implemented the two new rules in our drawing. In the first step, we joined the center of this semicircle that is at this point, point B, with the center of this circle that is located here at point F by a straight line. So this semicircle have an external length between with this circle, that is to say, they are touching each other externally in point H. And therefore, according to rule number 11, whenever we have an external length between two circles, the straight line that connects their centers together, that is to say BF, B is the center of this semicircle, F is the center of the circle. And the straight line that connects their centers together is BF. This straight line BF must pass for their touching point, that is to say from point H, that is their touching point. That is to say BHF is one straight line. BHF is one straight line. And what is the distance BF between their centers? The distance will be equal to FH plus HB. FH is small r, it is the radius of this circle. HB is the radius of this semicircle that is equal to 70 units. Therefore, in total, BF equals to 70 plus r units. Yeah, BF equals to 70 plus r units. Likewise, we calculated the distance between the center of the smallest semicircle and this circle. The center of the smallest semicircle is located at point D. Here, the center of this circle is located at this point, point F. And the straight line that connects their centers together is DF. So this circle and semicircle have an external arc between them at point G. That is to say, they are touching each other externally at point G, and therefore the straight line that connects their centers together, that is to say DF, must pass for their touching point, that is actually point G. That is to say, DGF is one straight line. DGF is one straight line, and therefore the distance between the centers DF, or the length of line segment DF, must be equal to the radius of this circle, that is small r, plus the radius of this smallest semicircle, that is 35. That is to say, DF equals to 35 plus r, or FD equals to 35 plus r. Then we calculated the distance between points B and D, that is the center of this semicircle and the center of the smallest semicircle. From the drawing, it is very easy to see that BD, the length of BD, equals to 35 plus 35 plus 35. Okay, 35 plus 35 plus 35. That is actually 3 times 35 is 105 units. So we found out that BD equals to 105 units. Then we connected the center of the biggest semicircle that is located at this point, point O, with the center of this circle that is located at this point, point F, by a straight line. So according to rule number 10, because of the fact that we have an internal arc between this circle and the biggest semicircle at point I, that is to say, the circle and the biggest semicircle are touching each other internally at point I. And whenever you have an internal arc between two circles or semicircles, then the straight line that connects their centers together, that is to say OF. Why? Because O is the center of the biggest semicircle and F is the center of the circle. And the straight line that connects their centers together is OF. This straight line OF must pass through their touching point. Their touching point is point I. So OFI is one straight line. OFI is one straight line. And therefore, we know that IF is the radius of this circle. OI is the radius of the biggest semicircle, that is equal to 105 units. And therefore OF, here OF equals to OI minus FI. Again, OI minus FI equals to OF. OI minus FI equals to OF. Repeat again, OF or FO equals to OI minus FI. OI equals to the radius of the biggest semicircle, that is equal to 105 units. Fi is the radius of the smallest of this circle, that is equal to small r, and therefore OF or FO will be equal to 105 minus small r units. So here F4 equals to 105 on small r units. So in the next step, I will present to you a new rule, and we implemented the new rule in this green triangle FBD. The new rule is thrown in any triangle, so this triangle ABC, could be any triangle. We know that the length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. And line segment AO equals to D units in its length. Line segment BO equals to M units, and finally line segment OC equals to N units in its length. Then, according to Stewart's theorem, the following equation will be true. That A squared times n plus B squared times n equals to C is the length of side BC, times B squared plus M times n. Okay, I repeat again, A squared times n plus B squared times m equals to C times D squared plus mn. We implemented the Stewart's theorem in our triangle FBD. So I copied triangle FBD in a new page, and we implemented on it Stewart's theorem. We have already found out all the sides of this triangle, so I will not repeat on it. We already found out that FO equals to 105 minus R, OD equals to 35 units. Here, actually BO equals to 35 units, and here OD, from the drawing it is very easy to see that OD equals to 35 plus 35, that is 70. Again, BO equals to 35 and OD equals to 70. So we implemented here Stewart's theorem. According to Stewart's theorem, FB squared times OD plus FD squared times BO equals to here BD times, inside the brackets we have FO squared plus BO times OD. I repeat again that FB squared times OD plus FD squared times BO equals to BD. Inside the brackets we have FO squared plus BO times OD. Okay, so this equation is the implementation of Stewart's theorem in our triangle FBD. FB equals to 70 plus R, so if FB equals to 70 plus R, it means that FB squared equals to 70 plus R squared times OD. OD times OD. OD is 70, so we substitute OD by 70 plus FD square. FD is 35 plus R, therefore FD square is 35 plus R square times BO. BO is 35, so we substitute BO by 35. And it is equal, in the other side of the equation we have BD. BD is 105, so we substitute BD by 105. And inside the brackets we have FO square. FO equals to 105 minus R, therefore FO square equals to 105 minus R square plus BO times OD. BO is 35 and OD is 70. Okay. Then we defined 35 as x, and we substituted 35 by x, or any multiplication of 35 by a positive number, or not one number, we also multiplied by x. Okay, so here we have 70 is 2 times 35, so it is 2x plus r squared times 70 is 2x plus 35 is x plus r square times 35, that is x, equals to 105 is 3 times 35, that is to say it is 3x. Inside the brackets we have 105, that is 3x minus r square, plus 35 is x and 70 is 2x. So this expression in total equals to x plus 2x, x times 2x. So in conclusion, we got this expression. Okay. In the next step, we actually divided this equation by x. So here x will get cancelled, x will get cancelled, and here also x will get cancelled. What is left from this equation after we cancelled x? In this side of the equation we have 2 times 2x plus r squared plus x plus r squared equals to 3 times 3x minus r squared plus 2x squared. Here we open the brackets of 2x plus r squared. 2x plus r squared equals to 4x squared plus r squared plus 4xr times 2. X plus r squared equals to x squared plus r squared plus 2xr. On the other side of the equation we have 3, and inside the brackets we have 3x minus r squared is 3x squared, that is 9x squared, plus r squared minus 2 times 3xr is minus 6xr plus 2x squared. Then we multiplied this expression by 2. 2 times 4x squared is 8x squared. 2 times r squared is 2r squared. And 2 times 4xr is 8xr. Plus x squared plus r squared plus 2xr equals to, here we have inside the brackets 9x squared plus 2x squared is 11x squared. And we have also here r squared plus r squared minus 6xr. Then 8x squared plus x squared is 9x squared. 2r squared plus r squared is 4r squared. And we have here 2xr plus 8xr is 10xr. And the other side of the equation we have opened the brackets here. 3 times 11x squared is 33x squared. 3 times r squared is 3r squared. And 3 times minus 6xr is minus 18xr. So here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step, we subtracted 9x squared from this equation. 9x squared minus 9x squared is 0, so in this side of the equation we left only with 10xr. In the other side of the equation we have 33x squared minus 9x squared is 24x squared minus 18xr. Okay, here we found out that 10xr equals to 24x squared minus 18xr. Here we added 18xr to this equation. In this side of the equation we have 10xr plus 18xr is 28xr, and it is equal to 24x squared. 18x squared minus 18x squared is 0. So in conclusion we found out that the 28xr equals to 24x squared. Here we divided this equation by x. 28xr over x is 28r, and 24x squared over x is 24x. So in conclusion, we found out that 28r equals to 24 times x. Here we substitute x by 35 because according to our definition, x equals to 35. And we found out that 28r equals to 24x, but x is 35, so we substitute x by 35. So 28r equals to 24 times 35. Here we divided this equation by 7. 28 over 7 is 4. So in total, in this side of the equation, we have 4r. And we have, on the other side of the equation, 24 times 35 over 7 is 5. So we have, in total, on the other side of the equation, 24 times 5. So we found out that 4r equals to 24 times 5. Here we divided this equation by 4. 4r over 4 is r. And 24 over 4 is 6. In total, in this side of the equation, we have 6 times 5. So r equals to 6 times 5. 6 times 5 is 30. So in conclusion, we found out that r, the radius that you are looking for, or small r, the radius of the circle, equals to 30 units. Here, the radius of this circle that is equal to small r according to our definition, it is equals to 30 units. Okay? Thank you very much.